Hello everyone, this is Tommy signing on Energy Academy. Now I'm going to be talking about 4 reasons why we would always use fossil fuels. Now you might have heard about the Netzero agenda, that is to reduce our carbon dioxide emissions into the atmosphere and essentially reduce the amount of carbon that we use in our industrial process and the emission of carbon into the environment. I'm going to give you 4 reasons why that's never going to be successful. I'm not saying this to be a party pooper, or I'm not saying this to make you feel sad. I'm just saying this as an engineer who knows how things work, who understands the physics of the nature of our technology, and I'm just trying to communicate it to you so that in 5, 10, 15, 20, 30, 40, 50 years time, when you look around you and say, why are we still using all this fossil fuel to generate energy or to make stuff? You'll understand because I've told you about it. Now I said there were 4 reasons why I would always use fossil fuel. Now these 4 reasons are very important for human beings and for their survival. The first reason why we would always use fossil fuel is food. Now, very few people appreciate the fact that we use an awful amount of fertilizers, especially ammonia-based fertilizers. Now ammonia-based fertilizers are made typically using the Haber-Bosch process that has been around since around the Second World War. The Haber-Bosch process essentially combines hydrogen and nitrogen to form ammonia. And the hydrogen that we get is essentially sourced from methane, which is a fossil fuel, which is natural gas. Now the methane is heated up and the carbon atom is broken away from the hydrogen atom. The hydrogen atoms are removed, extracted, and then combined with nitrogen to form ammonia. And this ammonia essentially is what we use for our ammonia-based fertilizers. Now another important facet about using artificial fertilizer is that it decreases our land use. Now if you were to farm without the use of synthetic fertilizers like ammonia-based fertilizers, we will be using essentially half the world's land mass. But because of we use fertilizers, we're able to increase our yield on the same space of land, even though our population is increasing. That's why over the years, literally over the centuries now, we will be seeing a massive increase in the yield of farmland across the entire world, across different continents. So ammonia-based fertilizers, which essentially has its roots in methane, a fossil fuel, is what is keeping us alive and feeding billions of people around the world. If you take away that fossil fuel use, you will literally kill billions of people. And I'm not being hyperbolic about that. The second important reason why we wouldn't always use fossil fuel is shelter. Now, we don't just have shelter because we like to have cool looking houses. We use shelter to protect us from the elements, from the weather, from rain, from snow, from the heat, from the cold. Now, our shelters are mainly constructed from 3 major elements, that is cement, steel, and glass. Now, the most popular cement that we use in the world today is Portland cement. Now, Portland cement essentially is made by throwing in aggregates into a kiln. Now, the aggregate is made up of shale, clay, iron ore, limestone, silica, and these essentially are crushed and fed into a large cylindrical kiln. Now, this cylindrical kiln are 40-story longs and sometimes 12 meters in diameter. You can literally drive a car right through this kiln. Now this kiln are rotating whilst they are heated up by, you guessed, oil, gas, or coal. You need a lot of energy to essentially heat up this aggregate that's been fed into this kiln. The temperatures you see in this kiln is about 1,500 degrees Celsius or about 2,700 Fahrenheit. Now, there has been some technology that's come into place that means that you don't actually have to heat up the skin to as high a temperature. This technology by a company that I believe is called Solidia can heat up the kiln to 1,200 degrees Celsius, which is about 300 degrees Celsius lower than what we typically will heat the kiln onto, but you still need an awful amount of oil, gas, or coal to heat up this kiln. This is how we make cement. Now steel, for every 2 tons of steel that you manufacture, you need 1.7 ton of coal or coke, which essentially is treated coal. Now, coke can be derived from treated coal, or you can actually get it from petroleum-based products. Petroleum coke has a higher carbon content than coal that you might get from coal, now, which is sometimes preferable because you want a higher carbon content when you are trying to make steel. Now, the coke is essential for generating the heat used to heat up the limestone and the iron ore and essentially melt it. But also you need the coke to provide a carbon that is infused into your steel, because if you don't have an adequate amount of carbon, then you can't have useful steel. In fact, you can't really have steel. Carbon is required for steel. So that means you're always going to need carbon. Now, there has been some technology that's come about that means that you could potentially, essentially heat up the limestone and the iron ore without having to use carbon-based fuel. But you still need to put carbon into your steel to get you useful steel. That is what the physics dictate. According to the EIA, about 73% of the energy that is used within the glass manufacturing industry comes from natural gas. 73%. So you're not going to get rid of that anytime soon, because those fuel sources give you a lot of bang for buck. That's why they're heavily used. And as long as we're going to have houses made of glass, steel, and cement, we will be using a ton of fossil fuel to essentially protect ourselves from the elements. The third reason why we would always use fossil fuel is medicine. Now, I came across some phenomenal factoids when I was digging deep into this research. Now, according to some sources, 99% of pharmaceutical feedstocks and reagents are coming from petrochemical sources. Now, this is very important because when we think about our medicine, we don't think too much about petrochemicals and refineries and oil and gas. But a lot of our pharmaceuticals are derived from petrochemical sources. Aspirin, for example, very popular pharmaceutical that everybody knows about, has a particular function group in it called benzene. This is derived from petrochemicals. Now, there are a plethora of drugs that we are very familiar with, like antihistamines, antibacterial, cough syrups, creams, ointments, gels like hand sanitizers. We even have laxatives. Now, I don't need to tell you what laxatives are, that are derived from petrochemicals. And then there is the plastics. When we think about plastics today, we think about things that clog up the sewers, or plastics polluting the ocean, or plastics essentially being a nuisance to ocean life forms. But really and truly, the petrochemical industry has essentially enabled us to create plastic that has revolutionized the medical world. So things such as artificial limbs, joints, gloves, syringes, masks, soaps, hearing aids, dental aids, artificial cervical discs, artificial polymer skins, and even artificial hearts are made from plastics. Plastics literally are at the beating heart, pun intended, of medical advancement. The fact is, without petrochemicals, it becomes impossible for us to mass produce the amount of pharmaceuticals that we require to meet the world's demand. And then finally, transportation. When we think about transportation, we tend to think about vehicles like cars or even motorcycles or slightly larger trucks. But we don't think too much about the fact that what really moves goods and services around the society is not the cars and the motorcycles, but the real movers and shakers in the industry are the big boys. And I'm talking about the big boys. I'm talking about tankers. I'm talking about shipping containers that move hundreds of tons of freight across continents. I'm talking about massive air freight. I'm talking about massive combined harvesters for agricultural purposes. I'm talking about the heavies, the big boys in mining. All these massive different forms of transportation, like jets required to send payloads into space or into orbit. All these massive big boys of transportations require an awful amount of energy. Now, take for example flight. And the holy grail of flight technology to replace combustion engine within airplanes is electric engines. The problem is electric engines have about 30 times less the energy that jet fuel is able to generate. That means for 1 kilogram of jet fuel, you would generate 30 times more energy than 1 kilogram of battery. This is one of the biggest reasons why battery technology will never ever power commercial flights, will never power combined harvesters or massive shipping containers that transfer tons of goods from one continent to another. So these are the 4 reasons: food, shelter, medicine, and transportation, why I don't see anytime soon the replacement of fossil fuel either as an energy source or a feedstock, because they are essentially invaluable to the physics of how these things are made, and they're invaluable for the physics of how these things are shipped and transported around. So let me know what your thoughts are. If you think I don't agree with you and you think I believe that we can replace all these things with a new technology, I'd like to know what your thoughts are. I'd like to hear your ideas. If you think actually I agree with you, then give me a thumbs up and share this video with your friends, because the most important thing is that we have intelligent conversations about these issues. This is Tommy signing off on Energy Academy. Until next time.